Okay, so today we're talking about vertical kinematic problems. Okay, so far everything we've done has been in the horizontal direction, perfectly fine, made a lot of sense. We had initial velocity, final velocity, acceleration, displacement, time, right? We had those beautiful 3 kinematic equations. What if I told you now we have to learn 3 brand new kinematic equations on a whole new day at 2 o'clock in the afternoon? I'd be lying, which is really good news. The equations have not changed at all. I'm going to write them slightly differently. So this is the same equation. V final is equal to Vy naught plus Ay t. The next one is y is equal to y naught plus Vy naught t plus 1/2 Ay t squared. Last one. These equations are not new in any way. They are the exact same equations. I did not write them in a new, different way, except for I changed out the x's for the y's. These are not given on the AP equation sheet. They only give you the x direction ones, but our kinematic equations apply to either direction, but only one at a time. So I can either do the x direction, keep everything with x's, or I can use them for the y direction. Now that's why I'm really specific when I write these out, and I will be specific as we go through examples and using these variables. Because today it's just vertical. My tennis ball is just going to go up and down. Okay, that's it. Where did my tennis, oh, here it is. But next class, my tennis ball is going to go that way. Oh, good catch. Right over here. Next class, this tennis ball is going to go both horizontally and vertically. And that's going to be important to keep track of. So that's why I write this. If you're like, oh my gosh, do I have to really write all this y's? Oh, that seems really hard. A, it's not, so stop being a baby. And B, this is going to be really important because next class you're going to have an initial velocity in the x direction and the y direction. And if you just write v for everything, you're going to be like, well, wait a second. Is that the total velocity? Is it the y velocity? Is it the x velocity? I don't know. So that's why as we get into this new direction, I'm writing very specifically all the y's, so I don't ever get confused. But what we're about to do is the exact same as what we did last class. We are going to write out for a situation the givens, the unknowns. We're going to pick an equation. We're going to do the math. Nothing about this is different, okay? It's just a situation that's going to be vertical instead of horizontal. Here's the good news about vertical. Vertical comes with some guaranteed information, and that is the beauty of it. So, in the vertical direction, what is one thing we know for every single vertical question ever? Yes? Gravity. Acceleration due to gravity is always in the y direction. Ay is negative 9.8 meters per second squared. For every question. Remember on the AP exam, air resistance is negligible, so we can count on this. So it's like a horizontal question, except for we already know one thing every single time. So let's practice that. So I'm going to throw a volleyball. I don't know how I got a volleyball, but I have one. I'm going to throw a volleyball off the Eiffel Tower. I'm throwing it straight down. And I want to know how long it takes to get to the bottom. Anybody know off the top of their head the height of the Eiffel Tower in meters? Any have a guess? 1,600? Okay, I'm not playing that. Yes?
Like 1,800?
1,800?
No,
It is 330 meters. 330 meters.
Oh, well, that's like 6 or 7 feet.
No, it's actually actively not. All right, 330 meters. So we're going to write out everything that we know. We're going to choose an equation, and we're going to solve. Nothing is different. Before we even look at the question, because it says it's moving in a vertical direction, what is one thing that I already know? Gravity. Acceleration is equal to negative 9.8 meters per second squared. Cool. All right, got that one. Now let's read the question. What else do I know? Yes?
Initial velocity.
Yes, I'm throwing it. I'm through it. So we need to know, actually. Let's say I'll drop it. I'll drop a volleyball. Dropped the volleyball. I dropped it. Okay, what's the initial velocity if I dropped it?
Negative 9.8.
No, that's the acceleration. 0, 0, 0, 0. Yes. If I dropped it, my initial velocity is 0. I know one more thing. I know it because I see another number in there.
Distance.
Distance, what is it? You sure about that?
Negative 330.
Negative 330. Why is it negative?
Because you're going down.
It's going down. I didn't throw the volleyball up 330 meters. I watched it drop down 330 meters. So delta y is negative 330. As a reminder, I did this when I had them in the vertical, but I always typically rewrite this equation to be delta y is vy naught t plus 1/2 ay t squared. And this guy is the same thing, but this is delta y. I keep those in my back pocket because very, very rarely do I have my initial position and my final. In this case, I do, right? My initial position would have been 330, and my final position would have been 0. So I could have used y and y naught, but I like to write delta y. It's easier. It's one number instead of two. Yes, Varna.
Would it not be multiplication in the second equation?
Multiplication in the what do you mean? Here?
Oh, no, a second equation on the first.
Yeah, I'm just saying that this is, I put that there.
Oh, no, second from the top. It's like y is equal to y0 plus y.
Y is equal to y. No, all I did was subtract this over here. So y minus y naught is equal to delta y.
Would it not be y is 0 multiplied by y?
Nope. This is just y0 by itself. So I just subtracted and got y minus y naught is equal to vy naught t plus 1/2 ay t squared.
Okay, yeah.
So then that's just delta y. Does that make sense? Yeah. All right. So now we're solving this problem. What are we looking for? We're looking for time. So pick an equation and let's solve. Which equation do we want to use? No.
No.
Okay, let's talk about this for a second. Don't wildly guess. No reason to make physics hard. Don't wildly guess. If you don't know how to choose an equation, let me tell you. I look at these 4 variables that I have and I match them to the equation. So on this first one, I don't have final velocity, so I can't use this equation. On this next one, I have delta y. I have initial velocity. I am looking for time. I have acceleration. I'm looking for time. I have everything I need except for what I'm looking for. Yes, what was your question as I write this out?
So you put initial velocity at 0. Would it be vy0?
Yeah. Yeah. Again, it's not required today. And when I do it next class, I'm going to write out a horizontal and a vertical to try and keep things separate too. But if you ever catch me, yes, it's not required. I do that to help myself in a question. But if I forget, it's because I do a lot of these. All right. Delta y is equal to vy naught t plus 1/2 ay t squared. So negative 330 is equal to 0 times t plus 1/2 negative 9.8 times t squared. So negative 330 is equal to negative 4.9 t squared. If I divide, I'm doing a little rounding. It's 66. Wow, a little rounding. How'd that happen?
You gotta round up, I think.
No. And then I'm going to take a square root. The square root of 66, again, doing a little rounding, is like 8.1. So this example with my tennis ball, right, just dropping, I dropped the volleyball off the top of the Eiffel Tower, right? As I drop it, this is what we're going to talk about as free fall. So we have just any random type of vertical motion. I only know this information, just the acceleration. For free fall, it's a slightly more specific type of vertical motion. It's denoted by either the question saying, this object's in free fall, or more likely it says it's dropped. Dropped is a key word you're looking for. If I say dropped, it means I didn't give it that initial velocity. So in free fall, I still know acceleration, and I also know initial velocity.
What do we round to?
Whatever you want. Okay. Make it not 18 decimals long, but like that's a personal choice. I'll leave that to you. I don't care. AP doesn't care, so therefore I don't care. That's pretty much the way that works. I want to show you something scary. Okay, we're not going to finish this problem. You can do it at home if you would like, but I'm going to show you something scary. Free fall, really nice. But originally I said I threw the volleyball down. If I did that, let's say I threw it at 10 meters per second. What changes on this list?
Initial velocity.
Initial velocity is negative 10. Here's where it gets scary. This is no longer 0. It's now negative 10t. And now I can't just solve this because it's a quadratic that I can't factor. And how do I handle a quadratic that I can't factor? I use the quadratic formula.
Wait, Miss Lambert?
Yes.
You know how when you squared the 66, you got 8.1? Does that have to be plus or minus?
That's a good question. Since it's time, I have both options right from math class. But since it was time that I was solving for, it has to be positive. So he asked when I took the square root of time, how did I know whether it was positive or negative? Typically, we're doing that for time, and so it's positive. If you solve this equation and take a square root, it's possible you might have to think about it and decide, should it be positive or should it be negative? So this is, I'm not going to solve it for you guys, but this is the scenario that'll end you up in quadratic formula land, okay? There's really only 2 ways to do it. For now, we're going to stick to this way. There's one more method I'll show you next class. But this is the main method. If I throw an object down and ask for time, quadratic formula is the only way out of that problem. Okay? Questions about this? Yes? You have a Desmos calculator during the AP exam. On my test, you will have the calculators that are out and about in my classroom, not your personal calculator. If you do not know how to use the calculators in my room, that's important. Let me put it to you a different way. I played around with the Casio. I'm not a Casio person. I'm a TI-84 every day, all day long. But if you play around with the Casio, I did this math because it was something that they needed for the test, and I saw a couple of students get it wrong. So they were solving something. This was like 12, and then this was 2 cosine 30t. So they divided 12 by 2 cosine 30, let's say. And they typed into their calculator 12, they pressed the divide button, and then they put 2 cosine 30. If you do that in the Casio, I noticed because I tried it, the Casio very nicely knows what you're trying to say and put the parentheses for them, for me. I ignored the parentheses and it added them after the fact. And then you get the right answer. On my calculators, that is not happening. If you type this without the parentheses into my calculators, it is only doing 12 divided by 2, so 6, times cosine 30. It's following PEMDAS, the original order of operations. So it does division, then multiplication, unless I put parentheses around it. So if you haven't come up with a reason why you should practice the math in this class on my calculator, I have found your reason. Do not let the calculator be your Achilles tendon. All right, last type of vertical motion, and the most fun, and has the most going on. Let's let things go up and down. Tennis ball. Haha. So up and down. Up and down. Okay? Here's the deal. That's a parabola. It's got a lot of symmetry to it. If I had the free time in this class, which we don't because it's AP Physics 1 and we got to learn a lot of stuff, I could derive for you why all of these things are true. But let's stick with the fact that it's a parabola and the acceleration is the same at all moments. So the first thing I know about up and down motion, first off, we need to separate it into up and down motion. There's only one scenario where you can solve the whole thing, and we're not doing it today. Here's why. What is the displacement if you do the whole up and down motion? 0. That's going to be a problem. If 0 is my displacement and I plug in 0, whoa, well, hold on a second. This whole term goes to 0, and I really can't solve for very much. Same thing up here. If the displacement is 0, oh no, I can't really solve for very much. So a strategy for up and down motion is that we solve either for the up or for the down. Okay? And here are the things that are true. First off, what's the acceleration in both directions the whole time? Negative 9.8. All right, let's talk about up first. If I toss it up, I gave it some unknown initial velocity. Cool. What's its velocity final at the very top? No, that's its acceleration. Yeah. 0 at the top. I'm telling you, that's the most missed question. And you're like, no, how could that possibly be? I'm proving it to you every time. But on the way down, what's my initial velocity? 0, right? Because at the top is the start of the down, right? And at the top, it's 0. So that's different information. Yeah. So when I'm solving the up, that's me going, okay, I launched the ball up and I'm stopping it up there. That's the only motion I saw was the up. If I'm solving the down, it's like I dropped it from the top. So I can only solve one half at a time because the displacement's the same at the end. Displacement's 0. So I can't solve for displacement for sure, right? Because it's 0. So I always find myself solving either the up or the down. Now, here's a fun fact. I don't care which one you do. You'll find, though, just in general, you'll lean towards this. Just kind of happens that way. But let's talk about a couple other fun facts. So these are the only things that we know, but another true statement is this. Because of the symmetry, my initial velocity is equal to the negative of my final velocity over there. So whatever velocity I throw this ball at, if it lands at the same height, it's going to hit my hand with the same velocity, just negative. That's because it traveled the same distance up and down with the same acceleration, and therefore it's going to have the same change in velocity. So however much the velocity changed going up is how much it changed coming down. Since it got to 0 at the top, that means the initial velocity is equal to the negative of the final velocity, right? Because I'm just going to have negative final velocity. That's a really cool fun fact. What about the heights? What can we say? The height on this side going up, right, has to be equal to the height on that side going down. That makes obvious sense, right? I'm watching it. Yep, whatever goes up must come down. Assuming I caught it at the same height. I didn't. I should be better at this than I am. I was in color guard in high school, so I threw a lot of things in the air and caught a lot of things, but clearly some of that has worn off by this age. Last thing, also very important. The time going up is equal to the time coming down. Those are also equal. There's a lot of symmetry. So my initial velocity is equal to my final velocity when I get down, except negative. The height it goes up is equal to the height it came down. Pretty obvious. And then, because it has the same initial velocity and final velocities, just positive and negative, so this change in velocity is the same, the acceleration is the same, time has to be the same. Now, here's a very important thing. Put a big star next to it in your notes. If the question asks for the total time in the air, right? Total time in the air. You only solved for half the time. You either solved the up or the down side. Only. You couldn't have done both. You either solved for up or you solved for down. So you only have half the time it was in the air. So total time would be 2 times whatever time you get from this or from that. Either of those are going to be equal, whether you solve the up or the down. That's not an issue. But if the question, and they will do this, if the question says, and how long was the ball in the air if it was launched at 10 meters per second, you can figure it out. You have an initial velocity, you have a final velocity, you have an acceleration. You can solve for time, but make sure you double it. Because you only ever solve for half of the time at a time. Okay, your question, then your question. Yes?
So if you, for example, if you have like initial velocity of 10,
Sure.
the ending, the initial velocity on the other side will also be negative 10.
Right. This final velocity would be negative 10. Yeah. If I started with 10, this would be negative 10. Yeah, Liam.
Kind of like that. I'm confused why it's negative. Because would it not just be like...
You're going down.
Because it's going down.
Okay.
That's the only reason,
But is it
right?
not like 0 whenever it gets to the bottom?
So that's a really good point. We are not talking about after I've caught it. These questions are always asking for the final velocity right before it hits the ground. That's a really important point, okay? Because everybody's like, well, and it doesn't work with this, but let's say I dropped, there's going to be air resistance. Ignore the air resistance. Okay, it landed on the ground. What's its current velocity? 0. But it's never talking about when it hits the ground. It's talking about the second right before it hits the ground. At that point, that's its negative initial final velocity. Yeah.
Okay, I know it's gonna sound like a stupid question.
No stupid questions.
How much different would it be? Like, let's say you start on a ledge, you toss the ball up, but it falls off the edge.
Right. That's a very good point. That's a completely different question that we're not dealing with yet, but we will get to. So your question is, I'm standing at the top of the Grand Canyon, 2 miles down. Okay, that's 2 miles. It is a dream of mine to run the rim to rim trek in 2 days probably. I don't know that I could do it in a day, but that means you start on the north rim of the, what's it called? Grand Canyon. You run the vertical 2 miles down, you run some distance in the canyon, and then you come up the other side and you do all of that in a day in theory. That's a goal of mine. I have really weird dreams, okay? Like when people are like, oh, what is the thing you want to accomplish in life? I choose really weird, not super fun ones. Anyhow, so I toss the ball here and it goes up and it comes down. At this height where I threw it at the same height, all of this is true, right? If I launched it at 10 meters per second up, sorry, this marker stinks. At 10 meters per second up, then here it would have negative 10 meters per second velocity. It would have gone up the same height. It comes down to this point. Everything after that is different, okay? But here's the great thing about this. If I do this, now I have a change in displacement, right? The ball fell from my hand, maybe 2 meters here, and then 2 miles is 3,200 meters, right? A mile is 1,600 meters. Good maths, good maths. So my change in displacement is a negative 3,202 meters. So now I have a change in displacement, so I don't have to do up or down. The whole list is back. I can use all of them again. If I land at a different height. If I keep the height the same, the displacement 0, so these no longer work to do the whole thing. I have to choose up or down. But in your scenario, if I launch something off of a cliff and it falls further, or somebody catches it in their hand prematurely, right? Then I can use these like normal. Yes?
So change in displacement, will we keep the origin at 0 or do we start at the 2 meters?
Well, in this scenario, I would say this is 0, right? All the way down at the bottom of the canyon. If you did this, then it's super yucky. I wouldn't do that. I wouldn't do that. You can, and then my displacement would just be negative 3,200 meters. if I started at my hand height, but technically my hand all the way down, I typically picked a ground as my 0. Yeah. All right, let's do a problem before we think, oh my gosh, this has gotten too complicated, we can't possibly. No. Let's do a problem and realize it's fine. Example. Make sure it's on my board. Yes. Miss Slimer throws a tennis ball. Wow, so unique. Up at, let's do 20 meters per second. I want to know a couple of things. I want to know, A, how high does it go? I want to know, B, how long is it in the air? So we're going to find both of those, okay? I'm going to try and do this in just this little section of board so I can leave that up. But if it gets too gnarly, I'll erase that and move it. I want to demonstrate that I have enough information to solve in either direction. So, as I said, it's a personal choice whether you're an up solver or a down solver. It's a personal decision. Don't let anybody change your mind. Okay? You have the same amount of information typically in both directions. So, for example, if I write out the information I know in the up direction, I know that my final velocity is 0. My initial velocity is 20. My acceleration is negative 9.8. And I'm looking for displacement. In the down direction, I now know my initial velocity is 0. What is my final velocity? If I'm going down, what's my final velocity? I launched it up at 20.
Negative 20.
Negative 20. Acceleration is still negative 9.8. And I'm still looking for displacement. This is me proving it does not matter. Choose up or choose down. Just know that you're only solving 1/2. Okay? Only the 1/2. Unless we throw things into off of cliffs, which we can. We'll do later. So I typically choose up, so that's what I'm going to show. Down, you will get the same answer, but will it be positive or negative? Negative, because it fell down. That's fine. You can still answer how high did it go. Just make sure you say the positive number. So again, since this is a very commonly asked question, doing the up just saves me from headache. Down is fine. Solve it with the down if you prefer. All right. I've got lots of things. Which equation do you want to use? 1, 2, or 3? I don't have time. 3. 3 is the only one that does not have time, right? So I'm going to have to use that one. So Vy squared is equal to Vy naught squared plus 2a delta y. So 0 is equal to 20 plus 2 times negative 9.8 times delta y. Much more common with vertical questions, I'm going to let you solve this for a minute. Much more common with vertical questions than horizontal, because in the horizontal we just always say that it's going in a positive direction. Pretty simple. And there really doesn't end up being a lot of negatives. Maybe they're slowing down so acceleration's negative. Maybe. But in vertical, since it's always going up and down and acceleration's always negative, pay attention to your negative signs. Okay? The most common issue is that you go to square root something, you're like, oh my gosh, I have a negative number, I'm square rooting a negative. No, you're not. You messed it up. Something's wrong. You're not square rooting a negative number. We don't live in an imaginary world. We live in the real physical world. There's a real physical answer. So you've messed that up.